Earth is tilted by about 23.5 degrees. We learned that number in school because it explains seasons. But today, I want to ask a different question. What if that tilt didn't just change sunlight? What if it also nudged how our planet moved, cooled, and organized itself long before the continents looked anything like they do now? I'm building a hypothesis. Turn this into a documentary for a second. If continents really drift, the Atlantic Ocean is the biggest crime scene on Earth because it looks like someone split a supercontinent down the middle and erased the seam with water. You've probably seen the classic image. South America kind of fits into Africa like a puzzle piece. It's tempting to stop there, but geologists don't trust coastlines. What do you match instead? You match things that don't wash away. The ages of rocks, the patterns of mountain belts, and the deepest cores of continents, the Cratons. In other words, we're not going to solve this by dragging continents around until the shapes look good. We're going to treat the Atlantic like a ripped photograph and use the oldest paper in the photo to line it back up. Here's the storyline. Today, South America and Africa are separated by thousands of kilometers of ocean. But if you rewind geological time, they were neighbors, part of a southern supercontinent called Gondwana. First, overlay simplified Craton blocks, the ancient cores that are billions of years old, and see how the deep pieces can be reconstructed across where the Atlantic is now. On the south next level, mountain belts and deformation zones that can be traced from one side to the other in reconstructions. That's the kind of evidence that makes continental drift feel less like a theory and more like a solved case. And this is why Cratons matter for our bigger question. If you want to ask what shaped continents early on, you don't start with coastlines. You start with Cratons, because they're the parts that remember the earliest chapters of the story. So, how do you go from neighbors to separated by an ocean, not by continents swimming around by a plate splitting? In the middle of that new ocean, you get a mid-ocean ridge, an engine that creates new seafloor. As that seafloor spreads, the continents ride away from each other. The edges that face the ocean become what we call passive margins. Not quiet in the deep past, but quieter than active plate boundaries like the Pacific Ring of Fire. Mountain belts get cut in half, rock provinces end up on different continents, and the only way to reassemble the story is to follow the oldest, most consistent pieces. Again, Cratons, ages, and structures. Subscribe for more like this.